So the first thing we need to do is to calculate the fixed period, which is P, given by the expression I commented before. And we substitute the values up here for this expression. We get a period of 0.5 months. So roughly every 2 weeks, we will place an order, which means exactly placing 2 orders per week. Second, we need to quantify, which is this R level, the up to order level. So remember that this is calculated as the demand or the average demand during that 0.5 month, those 2 weeks, plus the demand during the lead time, plus some extra safety stock to make up for the case where the demand is too high. So we need to calculate two terms, the average demand during P plus LT, and since the lead time is 0.25 months and our fixed periods have a month, we have a P plus LT, which is 0.75 months. Since on average we have a demand of 1,000 computers per month, during that period, during that time here, which is the time where we need to make sure we have enough inventory to meet our demand, that means having an up to order level of 750 computers plus the part corresponding to the variability of the demand during that period. So we need second to calculate the standard deviation during that time. So we apply the formula we saw before, and the standard deviation during P plus LT is the standard deviation of the demand during 0.75 months, which is the square root of 0.75 times the variance of the demand during 1 month. In this case, the demand has a standard deviation of 200, which means that the variance during a month is 40,000 units, and that gives us, when we calculate that, a standard deviation of 173 computers per month. So what we can now is calculate that up to order level, which is, remember, that 650 computers plus a number of times standard deviation during the time, which is the fixed period plus lead time. So if we use one standard deviation or two or three, we end up having different values for the other up to level, the R value, which is 1 times 173 or 2 times 173 or 3 times 173, which gives us different values for R. The larger the value of R, the more costly our policy will be, but the less likely will be to have stockouts. So in this case, if we just add once the standard deviation during P plus LT, we have a probability of 84.1 of not having stockouts during that time. And the same with the other values, and we can calculate different probabilities using different numbers for K.